One breath. What did that cost? 4 elements make that breath possible, and not just the breath. Your food, your water, the air pressure keeping you alive. Hydrogen, oxygen, carbon, nitrogen. These are not just useful resources among many. They are the volatile foundation of life and the bulk mass of vital materials. No substitution exists, no alternative chemistry work. So, where do they come from, and how do we find them? The 4 share a physical characteristic. They are volatile. Given heat and time, they escape. Given cold, they stay. That shared behavior is what tells the settler where to look. Wherever a world holds an atmosphere, all 4 are likely present in some form. Nitrogen as a gas, carbon dioxide carrying carbon and oxygen, water vapor carrying hydrogen and oxygen. An atmosphere is no guarantee, of course, for finding all 4 in useful concentrations. The atmosphere composition varies, but an atmosphere is a strong positive signal for all of them. Cold traps and permanently shadowed regions tell the same story. Wherever temperatures stay low enough to hold volatiles frozen across geological time, hydrogen, carbon and nitrogen concentrate together and oxygen arrives with them in water ice and frozen carbon dioxide. And where a world has neither atmosphere nor cold traps, carbonaceous chondrites are the delivery system. Those are dark, unprocessed rock from the cold outer solar system, never warmed enough to lose its volatile cargo. Comets are the same story in icier form. Both have been arriving as impactor for billions of years to any place in the inner solar system, really. Seeding locations across the inner solar system with all 4 elements. The surface signal is readable. Dark, carbon-rich, chemically primitive material means volatiles were delivered and may have been retained. The primary survey question is therefore, is there atmosphere? Are there cold traps? Or is there evidence of primitive impactors? Any of those is good news for all 4 elements at once. But 3 of the 4 breath components also have independent fallbacks, mineral sources that survive long after atmosphere and ice are gone. Oxygen is in silicate and oxide minerals everywhere rocky materials forms. The 3rd most abundant element cosmically, the majority by mass of almost any surface hard enough to stand on. Even where atmosphere and ice are absent, oxygen is not a problem. Extracting almost anything structural from rock, iron, aluminium, silicon, other metals, requires removing oxygen from oxides. A settlement doing the ordinary work of manufacturing will be releasing a lot of oxygen as a useful byproduct. Carbon and hydrogen share a different fallback. Where liquid water once existed and acted on the right chemistry, it left mineral survivors. Carbonates, preserving carbon in solid stable rock, and hydrated minerals. Clays, serpentine, locking hydrogen into crystal structures. Both persist long after the water itself is gone. Ancient water history, readable from surface geology, is an independent source of both elements, even on a world that is now cold and dry. Nitrogen, on the other hand, has no such fallback, and thus often turns out a limiting factor. No mineral phase traps nitrogen reliably. No process concentrates it independently of cold or atmosphere, and settlers need it, not primarily as a buffer gas, though it does reduce fire hazard, but it is the molecular backbone of every protein and every meal. Amino acids are nitrogen compounds. Without a nitrogen source, the food system fails, regardless of how good the farming is. This is why an atmosphere, geologically persistent cold and/or a history of carbonaceous chondrite bombardment is critical. For nitrogen, without any of those, there is little hope. 3 other elements share the volatile character of this group: fluorine, chlorine, and iodine. All three are needed, but in such small quantities that sourcing is almost never a constraint. They tend to be present in adequate quantities wherever nitrogen is found. Argon is also generally present wherever nitrogen can be extracted. An inert buffer gas can fill out for nitrogen, but not actually needed for anything. 4 elements, all volatile by nature. If they are not in the atmosphere, they may be found frozen. Find atmosphere, find cold traps, or find remnants of the dark primitive impactors, and you will likely find all 4. Oxygen also hides in plain sight in every rock on every world. Carbon and hydrogen leave their record in mineral survivors long after the water that made them is gone. But nitrogen is in the atmosphere, or frozen, or not at all. This is the breadth of a space settlement.